Hello everyone, I am Dr. VRAO. Today I am here with the calculation of pH of weak acid and weak base. To understand the calculation of pH of weak acid and weak base, we should know about the concept of degree of dissociation. Degree of dissociation. Which is represented by letter alpha. Alpha. Degree of dissociation. I already told you the concept of degree of dissociation. Degree of dissociation is the ratio of dissociated species to undissociated acid or base or something else. I repeat, degree of dissociation is the ratio of dissociated species to undissociated acid or base or something else. For example, water can act as acid and base. H2O undergoes ionization. H2O undergoes ionization and it forms H plus ions and OH minus ions. It forms H plus ions and OH minus ions. Here I wrote double-headed arrow. What does it indicates, that double-headed arrow? What that double-headed arrow indicates? That double-headed arrow indicates incomplete dissociation, that is partial ionization of water. Whatever it is, water, acid, base, if we write double-headed arrow, that indicates partial ionization or partial dissociation of that water, acid or base, right? So it undergoes partial dissociation, that means that does not undergo complete dissociation. Okay, so already I told you that alpha is a ratio of dissociated species to undissociated acid or base or something else. Here the dissociated species, I shall take H plus ion. H plus ion is the dissociated species, and the undissociated and the water is, and here the H2O is undissociated water. So it is the concentration of dissociated species and it is the concentration of undissociated water. We know the concentration of undissociated water, that is 55.5 molar. That is 55.5 molar means 55.5 moles of water molecules present in 1 liter water. Okay, so 55.5 molar is the concentration of undissociated water. Then what is the concentration of dissociated H plus ion? We know the concentration of dissociated H plus ion, that is 10 power minus 7 molar. So 10 power minus 7 molar means 10 to the power of minus 7 moles of H plus ions present in 1 liter water. So out of 55.5 moles of water molecules, only 10 to the power of minus 7 moles of H plus ions are present. That shows to what extent that water undergoes ionization. 10 to the power of minus 7 by 55.5, this fraction comes out to be 1.8 into 10 to the power of minus 9. Usually we can write it as 2 into 10 to the power of minus 9. So, alpha is a measure for the extent of dissociation that undergoes. I repeat, alpha is a measure for the extent of dissociation that undergoes. Actually, undissociated water concentration is 55.5 molar and the dissociated H plus ion concentration is 10 to the power of minus 7. So, out of 55.5 molar water concentration, only 10 to the power of minus 7 molar H plus ions are formed. It shows that water undergoes partial ionization. That means it does not undergo complete ionization. Okay, whenever the water or acid or base undergoes partial dissociation or partial ionization, there exists an equilibrium between dissociated species and undissociated water or acid or base. Okay, so alpha is, what I want to say is that alpha is a measure for the extent of dissociation that undergoes. Okay, let us understand this degree of dissociation with simple numerical values. This is for your understanding only, right? For example, if we take water, it undergoes partial ionization. That means it gives H plus ions and OH minus ions. Okay, so if we take 100 molecules of water, if we take 100 molecules of water, okay, out of this 100 molecules of water, let us assume only one molecule water undergoes dissociation, because water does not undergo complete ionization. That's why we assume that only one molecule undergoes dissociation. That is, out of 100 molecules, only one molecule undergo dissociation. That means one H plus ion and one OH minus ion is formed. Therefore, alpha can be written as out of 100 molecules, only one molecule undergoes dissociation, undergoes ionization. Okay, out of 100 molecules, only one molecule undergoes ionization or dissociation. Okay, so 1 by 100 means 0.01. So 0.01 is a alpha, it is the degree of dissociation. So it is a measure of for the extent of dissociation that water undergoes. So out of 100 molecules, only one molecule undergoes dissociation. Okay, so this is, I hope you all understand this degree of dissociation. Okay, degree of dissociation is a measure. Degree of dissociation is a measure for the extent of dissociation that undergoes. Okay, so now we shall see the calculation of pH of weak acid and weak base. So pH of weak acid, pH of weak acid. Let us consider the weak acid, that is, let us say HX be the weak acid. Okay, the term weak acid means it does not undergo complete ionization. The term weak acid means it does not undergo complete ionization. It undergoes partial ionization or partial dissociation. whenever the species or a compound or something undergoes partial dissociation, there exists a equilibrium between the dissociated species and undissociated compound. Okay. So, Hx be the, let us consider the Hx be the weak acid. So, as it is weak acid, we can represent with double, we can represent its dissociation with a double headed arrow. So, it gives H plus and X minus ions. So, here I represent this with a double headed arrow. Whenever we write a double headed arrow, that represents, that indicates partial dissociation. That means that compound does not undergo complete ionization or dissociation. Okay. So, here Hx undergoes partial dissociation, that means that does not undergo complete dissociation. So, H, that gives H plus ion and X minus ion. For example, if we take 1 mole of actually initially if we take 1 mole of acid, 1 mole of weak acid at the initial stage, if we take 1 mole of weak acid, that is now at this stage the acid does not start, the acid not yet start ionization. In such case H plus ion or OH minus ions are 0. When the acid starts ionization, some extent of quantity undergoes dissociation and it forms some amount of H plus ions and X minus ions. After that after dissociation starts, there exists a equilibrium between dissociated species to undissociated acid. Okay. So, at equilibrium, and it establishes equilibrium, and at equilibrium, for example, it if out of 1 mole of acid, alpha amount of acid undergoes dissociation. So, alpha amount of acid undergoes dissociation. So, alpha amount of H plus ion, alpha amount of X minus ion is formed. Already I told you that alpha is a measure for the extent of dissociation that undergoes. So, alpha amount of acid undergoes dissociation and to form alpha amount of H plus ions and alpha amount of X minus ions. Okay. So, usually it is an acid Hx, we consider the acid is we are considering the calculation of pH of weak acid or weak base, where it is when we concerns with acids or bases or solutions, it is customary to quantify the solutions in concentrations. So, we should multiply these terms with the concentration term, C into 1 minus alpha, C alpha into C alpha. Okay. I hope you got this point. Okay. So, here we take 1 mole of weak acid, we take 1 mole of weak acid. Okay. Alpha amount of out of 1 mole of acid, alpha amount of acid undergoes dissociation and it forms alpha amount of H plus ions and alpha amount of X minus ions. Since acid is a solution, acid is a liquid, acid is a solution, acids or bases is a solution. In chemistry, it is customary to quantify the solutions in concentrations. That is why we should multiply this value with concentration term. concentration C into 1 minus alpha into C alpha C alpha. Okay, I already told you whenever the species or acid undergoes a partial dissociation, there exists an equilibrium. So it is a equilibrium reaction. So we can write a equilibrium constant. We can write equilibrium constant or dissociation constant. Here the acid undergoes dissociation, so its equilibrium constant is called as dissociation constant. Here this is the acid, so that's why we can call it as acid dissociation constant. So acid dissociation constant is nothing but equilibrium constant. Okay, so equilibrium constant, we can write the equilibrium constant as a concentration of products by concentration of reactants. Concentration of products or concentration of H plus and concentration of X minus by concentration of reactants. So here the concentration of H plus is C alpha. That means when we multiply the degree of dissociation with the concentration term, that gives the concentration of dissociated species. Okay, so concentration of H plus is C alpha and concentration of X minus is C alpha and concentration of HX C into 1 minus alpha. Please keep this in your mind that these concentrations are equilibrium concentrations. These concentrations are equilibrium concentrations. Okay, so usually we take a weak acid, weak acid that is weak acid. For weak acid, degree of dissociation value alpha is less than 1. That's why it is weak acid, because alpha value, that is alpha, already I told you alpha is a measure for the degree of dissociation that undergoes. Since it is a weak acid, that's its alpha value is less than 1. Whenever alpha value is less than 1, we can take 1 minus alpha as 1. From the fundamental rules of mathematics, if alpha is less than 1, we can take the 1 minus alpha as 1. 1 minus alpha as 1. So 1 minus alpha is equal to 1. So therefore this dissociation constant transformed as C square into alpha square. C into 1 minus alpha can take the form can take it as 1, therefore C. So here we can take the C alpha square, C alpha square. So K acid dissociation constant Ka is equal to C alpha square. From this we can write alpha square is equal to Ka by C, Ka by C. From this we can write alpha is equal to root Ka by C, root Ka by C. For the calculation of pH, we need the concentration of H plus ions. So concentration of H plus ion is what is the concentration of H plus ion? C alpha. So C alpha is the concentration of H plus ion. Okay, so concentration of H plus ion is C alpha, and we can write we have the value of alpha, C alpha. If you substitute the value of alpha, that is Ka by C. Okay, we can write this C as root C into root C. So root C, the multiplication of root C into root C, that gives C. Okay, so it is root Ka and root C. Okay, so it gives root C cancel, and it gives root C Ka. So concentration of H plus ions is root C Ka. So, finally, we obtained concentration of H plus ions. Okay. So, it is enough to calculate the pH. So, we need H plus ion concentration to calculate the pH. Okay. So, now we shall calculate the pH of weak acid. From this, from the dissociation of weak acid, we get the value of concentration of H plus ion. So, concentration of H plus ion is root CKa. Okay. This can be written as CKa power whole power 1 by 2. And actually, what is our aim? To calculate the pH of weak acid or weak base. So, what is the definition for pH? pH is negative logarithm to the base 10 of concentration of H plus ions. Here we got the concentration of H plus ions from the dissociation of weak acid, that is minus logarithm to the base 10. Concentration of H plus ions is Ck whole power 1 by 2. Okay. From the logarithmic rules we can write it as 1 by 2 log C minus 1 by 2 log Ka. 1 by 2 log Ka. Okay. We know that minus log Ka is equal to pKa. Okay. Or minus log concentration of H plus ions is equal to pH. Similarly, minus log Ka is equal to pKa. So, minus log Ka, this can be written as pKa. So, minus 1 by 2 log C minus pKa by 2 minus log Ka, that is minus log Ka is pKa. So, pKa by 2. So, therefore, pKa by 2 minus 1 by 2 log C, this is the pH of weak acid. So, this is the formula for weak acid, pH of weak acid. So, pH is pKa by 2 minus 1 by 2 log C. Okay. So, here why we performed all these calculations? Because this is a weak acid. Weak acid does not undergo complete dissociation. Okay, that means it undergoes partial dissociation. So, whenever the compound undergoes partial dissociation, we need to discuss the degree of dissociation. We need to discuss its degree of dissociation. So, we performed this calculation and finally we came to know the concentration of H plus ion is root CKa, and from that we calculate the pH of weak acid. Okay. So, now we shall calculate the pH of weak base. Okay. pH of weak base. pH of weak base. Okay. In this case also we can take weak base and its dissociation reaction, and at equilibrium we can write the equilibrium constant and we performed the similar calculation. Finally, we get the concentration of OH minus is root CKB, because CKB. Why I am writing KB? Because it is a weak base. So, it is a dissociation constant of weak base. That is why I represent the letter with subscript letters B. Okay, so concentration of OH minus ion is equal to root CKB, and it can be written as CKB power whole power 1 by 2. Okay, in the case of weak base, okay, we finally get the concentration of OH minus ions. When we know the concentration of OH minus ions, we can calculate the POH only. We cannot calculate the pH. Okay, first we shall calculate the POH of weak base, then we can calculate the pH. Okay, so POH is negative logarithm to the concentration, negative logarithm to the base 10 of concentration of OH minus ions. So negative logarithm the base 10 concentration of OH minus ions is CKB whole power 1 by 2. Again it can be written as 1 by 2 log C minus 1 by 2 log KB. Okay, so minus 1 by 2 log KB. So minus 1 by 2 log C minus 1 by 2 log KB minus log KB can be written as a PKB by 2. Okay, so PKB by 2 minus 1 by 2 log C. This is the POH of a weak base, but we need to calculate the pH of weak base. We know that pH plus POH is equal to 14, and pH is equal to 14 minus POH. Okay, so we know the value of POH and we can get the value of pH. pH is equal to 14 minus POH. Therefore 14 minus POH is PKB by 2 minus 1 by 2 log C. So finally we can write the pH of a weak base as pH is equal to 14 minus PKB by 2 minus into minus plus 1 by 2 log C. So this is the pH of a weak base, and this is the pH of a weak acid. Okay, this is the pH of this is the equation for pH of weak acid, and this is the pH of this is the equation for pH of a weak base. Okay, so I hope you all understand this concept. In the next video I shall come up with problems based on pH concept. Thank you.